Now, let's talk about combination. Combination is about selection of different groups of items or sets. How do I mean? You know, when we were dealing with permutation, we have something like this: A, B, C, D, A, C, D, E, etc. We can also have B, C, D, A. In arrangements, you can see there are different arrangements. Different arrangements. But they are the same selection. They are the same selection. Let's assume I have 6 group of people here. Let's say I have A, B, C, D, E, F here. Here I have G, H, I, J, K, L. And I want to select team. Team here and team here. You know, if I select A, B, C, D, I select G, H, I, J here to play against these people. That's a team. So team A, team 1, team 2. If I say, okay, from this place I want to select B, C, D, A, and this one decides to select H, G, I, J. It's the same thing, the same set of people playing against each other. So this is selection. So all this one we have here, it is one selection. All this one, and this one, same selection or combination. Same here too, but different arrangements. Different arrangements. Same here. Let's talk about arrangements. Let's say, okay, we are selecting these four people in a to play small game of football. A can be at the goalpost. B can play the left. C can play the right. And D forward. That's an arrangement. Again, we can bring D here and A here. That's another arrangement. But if you look at it, it is the same selection. So I believe with this, you have understood what combination really is. Now let's look at what kind of calculation you can do under combination. Now, look at this. A, B, C, D. If I want to arrange this, I can have 24 arrangements. If I want to select 3, if I want to say, okay, arrange, how many arrangements of 3 can I have from here? You understand? I say, okay, for 3, I can have the same thing as in 4, the same thing, 24. But if I have just A, B, C, I have 6 arrangements. Same thing if I have 2, I have 6 arrangements. And you know the formula for this, you have this one to be n factorial. You understand? And this one is np3. As in, sorry, 4 factorial should be here. This one should be 4p3. Here, I have 3 factorial or 3p3. Here too, I have 3p2. But one thing is sure. You see, everything here in this first one, for this ABCD, how many selection can I make here? Selection or combination? Is 1. That's for this one too. For this one ABC, this is if all 4. This one is if all 3. Selection or combination is 1. Because no matter how I arrange them, I'm still going to have all of them in the same group. But if you look at this one, you know, this one is the same thing if it's arrangement. This one is the same thing if it's arrangement. But if I say, okay, out of this, what's it called? A, B, C, D, I want to make selection of 3 or combination. You know, by the time you look at it, all of these arrangement that is possible with this. Yeah, that is possible here. I'm going to have something like A, B, C, A, B, D, you know, like that. This selection is different from this one now. This selection is different from this one. And by the time you look at it, I can make this arrangement. But if you look at the arrangement, yes, A, C, B is different from A, B, C in arrangement. But in selection, they are the same thing. Selection here and this one, they are the same thing. So we realize that selection will be a factor, you understand, of arrangement. Or let's make it like this. Arrangement will be multiple of selection. That is, permutation will be multiple of combination. Now, as I was saying, I said that permutation is multiple of combination. Now, let's look at something. I have told you that there might be the same selection or the same combination, but there will be different arrangement or different permutation that will be counted here. Now, if I have n objects and I want to select R objects, I want to select R objects. You know, the way to the way to represent the combination, we represent it like this: NCR combination. But if I arrange these R objects, just like I showed you the other time, the number of arrangements is going to be R, P, R. You understand? It's going to be R, P, R. And that is arrangements of R objects out of R objects. And if I want to arrange R objects out of N objects, it will be N P R. Arrangements of R objects out of N objects. Therefore, N combination R times R permutation R is going to give us N permutation R. N permutation R. So, NCR will now be equal to NPR over RPR. And we know the formula for, so let's make it like this, will be NPR times 1 over RPR, which will be N factorial over N minus R factorial. That is for this one. Now this arrangement is 1 over R factorial. So N combination R, that is why we are looking for the number of selection or combination, is going to be N factorial over R or N minus R factorial times R factorial. So I like how somebody expressed it for ease in cramming. When it says number of objects to be selected from factorial over number of selection, object selected, factorial times objects, number of objects not selected, factorial. So you can see it makes it very easy. So which means that in the same way, you can easily say NPR will be equal to number of objects to select select from factorial over number of objects not selected. Factorial. So it makes our, cramming very easy and fun. So with this, when you ask how many selection is possible, it's NCR. How many arrangement is possible, it's NPR. That is all. Just understand the factorial and then, but it's always good to do your fundamental counting system in so many situations. Let's look at some examples. Now look at this. It says, in how many ways can 3 fish be selected from a bowl containing 7 fish? It is selection. It is about picking, not arrangement. So what we need to do is, this one is 7C3. That's the answer. That is 7C3. So you can also, there's another way of notifying combination. Let me use it. You can have it like this, NR. So in this instance, you can say 7, 3, like this. So it's also acceptable. So you can easily say this to be 7 factorial over 7 minus 3 factorial divided by 4n by 3 factorial. So that's the answer. Now let's look at this. In how many ways can 3 fish be selected from a bowl containing 7 fish and 2 potatoes? I told you, this topic, permutation, combination, and probability, is a very logical thing. And I can assure you, most of these IQ tests is taken from the perspective of combination and permutation, along with probability. So it says, in how many ways can the fish be selected from a bowl containing 7 fish and 2 potatoes? This selection does not involve potatoes at all. So in this instance, our answer still remains 7C3. That's all. So, because it says how many fish, how can 3 fish be selected from here? The selection will not involve potatoes. So that one is solved with ease. In how many ways can 5 books and 3 magazines be selected from 8 books and 6 magazines? The other time when we were talking about 3 fish from 7 fish, we just dealt with the fish alone. So now it is specified. 5 books from 8 books, 3 magazines from 6 magazines. So let's look at that of 5 books. For books, we have that one to be 8C5. For magazines, we have that one to be 6C3. So total, because it is combination of the books and magazines, you understand, not separately, is 8C5 times 6C3. That is combination for books multiplied by combination for magazine. Look at this. It says a team of 5 is to be chosen from 6 women and 5 men. Find the number of possible teams in which there will be more women than men. You see, in this situation, and the immediately past question we just solved, these are the situations where we have conditions. Condition that says, okay, 6, 3, 5 of this, 2 of this. In this instance, it's not telling us. Find the number of possible teams in which there will be more women than men. Ordinarily, if this condition is not there, the total possible selection would have been 6 plus 5, that is 6 men plus 5 women, combination 5. Ordinarily, if these conditionalities are not there. But now, since you have these conditions, let's see what are the possible, mix that we can have. So, if we are going to have more women than men, we are going to have it like this. See, women, men. The first situation, women can be 5 and men can be 0. It is possible because women is up to 6. That is, women can be the only ones in the set. Now, we can have 4 women, 1 man. You see, that one is also possible. We can also have 3 women, 2 men. Any other form of combination will make men to be greater than women. So from here, let's see. For women, here, the combination is going to be, the selection now is going to be, let's say, women, men. Total. For each possible selection. Here we have women. Here now, since women are 6 in numbers and men are 5, so we can have 6C5 and 5C0. This one is 1, this one is 6. So total is going to be 6 times 1, which is 6. Here, for this selection, we have women can be 4 and men can be 1. We have 6C4 and 5C1. This one is equal to 5, and this one will be equal to 6 times 5 over 2 factorial. This one, I think this one is going to be 15. Let me calculate it. So this one is 15. So possible, for this situation, you can have 15 times 5, which is 75. For the last one, here we can have 6C3 and 5C2. So this one is going to be 10 times 4 over 2 factorial. That's 10. This one is 6 times 4 times 3 over 3 factorial. I think this one should be 20. So we have this one to be 20 times 10, which is 200. So total possible selection. Yeah, men. Yeah, women are more than men. Will be equal to 6 plus 75 plus 200, which is equal to 281 weeks. That is for this.